when you're ready to break everything, or at least this teacup.
We're ready to break the cup.
Yeah, okay. No, it's not a wine glass, is it, Wayne?
It's made of pot.
So you need a low frequency.
You do.
Alright, okay.
Try again.
Nothing for me.
Not really, no.
It's got to be a bit. No. Not today then. So we should explain what we're doing. We're not just crazy and singing at cups.
We're on to resonance in the book, and we thought we were going to go to resonate things.
Yeah, because a good example of this, there's a few people who have done it, I think there's a world record doing lots of them, of a woman holding a wine glass, or a very clean wine glass, and singing at a certain pitch, and it's shattered, and it's all to do with resonance.
It is. So, as you hold the wine glass, its particles are resonating. Inside it will have an amplitude, its crystalline structure.
Yeah, and when you sing at it, you are providing a frequency which is then vibrating it more.
So the frequency at which this will shatter will be called its natural frequency.
Yeah.
And if you match that natural frequency as you sing to it, it's going to double the amplitude.
There'll be sort of like a super constructive interference there, so it'll be really, really high amplitude to cause it to shatter and molecules break apart.
Turns out mugs aren't quite as easy to do.
No, we thought maybe we could just wing it.
Yeah, didn't really happen.
Didn't happen there. But that's a shame, but I think we'll live.
I think we will. What we can do
is look at graphs.
We can, that's...
So we have an amplitude against driving frequency. Now, driving frequency is an important thing. The driving frequency is the thing you provide, whereas a natural frequency is the one of the object. So driving frequency can change, because you can change your input frequency, but the natural frequency will never change.
Yeah. And if we kept this driving frequency the same, then not much is going to happen.
No, assuming that the same isn't its natural frequency.
Yeah.
Yeah.
But as it goes over time, we see some variation in the amplitude of the thing you're firing at. So the molecules in the cup are going to resonate more until they reach a max, which is when it shatters.
So we could draw a graph of this. So you may try lots of different frequencies, and then there will cause really, really high amplitude.
Yeah. And say this point is the natural frequency. This is when it would shatter.
Yeah.
So if you hit it with exactly this frequency, that's when it shatters. But if you go above or below, it's just gonna vibrate a little bit at these points. It's not gonna do much for really, really high and really low. You can't just do a very, very high note and shatter glass. That's not how it works.
It's not actually very specific note.
Yeah, and that's why it's hard.
So that is the natural frequency, and this is changed driving frequency. But you can also apply dampening to all of these things.
And we spoke about dampening before. You can have your light, your heavy, and your very heavy.
And this is how much you decrease the amplitude.
Yeah. So that's what damping is. It's when you purposely decrease the amplitude. So for light dampening, it doesn't do very much. It just has a slightly lower one.
But say for heavy dampening, to do a different colour, maybe orange, because orange is always exciting.
I do like orange.
Orange is... I've never seen an orange pen before.
Only Edding a Bic. I haven't found a Bic one that
No.
It's a shame.
It's a shame. So it will be affected much more, start at the same point, but also, it's a bit too much of an extreme peak there. It will move slightly to the left.
Yeah, so this point where the glass would shatter has been moved to the left as well. So
and this will happen more severely the heavier dampening you put on.
At this point, the exact frequency it would go is at this point, so we'll call that F2 and that F1. It's now shifted to the left of this. You need a lower frequency. And I'll do one final one in green.
Yeah, it is.
Where it might be very heavy dampening.
Extremely dampening, so think of your trolley on a...
And then that's right down here. So it depends which book you have. They might have drawn 3 different ones. They might have just explained it, or they might do some sort of upward line.
Yeah,
like
so
this.
they were like a curved line showing that it peers through all the points.
What you need to know is that if you dampen things, you're going to shift the frequency about of the
resonant
maximum.
frequency.
Yeah, the resonance.
So natural won't change, but our resonance point where the highest amplitude will occur will.
Yeah. So I think we should go try and shatter some glasses. Apparently they're easier than mugs.
Maybe. Alright, let's try that.